Engineering Eng. PDF document of this video is on engineereng.com.
Hello my friends, I hope you are well. In this video, how are the transitions between coordinate systems provided? I would like to give information about this topic. Normally, even in the books we call good, this is given and passed on readily, but here we will try to explain with the logic of this, namely what comes from. First of all, a direction vector is written as, let it be the ith direction vector. It is divided by the metric of the direction vector and the vector r of the corresponding coordinate system is derived. So what did I mean? For example, if we want to find the equality of cylindrical coordinates in terms of Cartesian coordinates, let's define the first element of cylindrical coordinates, e rho. Then it says take derivative according to what? So write the vector r and derive it with respect to rho. Now then, one of the important points for me is to be able to write that r over here somehow, okay? Then I need to be able to express this r. Remember, first of all, how we were writing this in Cartesian. We already know that there are x as many as ex, y as many y ey, z as many as ez. In order for me to derive with respect to rho, I need to be able to write the equivalent of this in cylindrical coordinates. Remember this for the x rho cos phi e x plus for y rho sin phi e y plus, and for z, you know z already in the cylindrical coordinates, so z written as z. Okay, let's rearrange here. E rho, h rho is 1 because it is already a length metric. Here comes the ratio of 1 divided by 1, so I don't write. I automatically derive r with respect to rho. Okay, this is enough. So let's find E rho here. E rho equals, friends, what it says, take the vector r derivative with respect to rho. If I take the derivative with respect to rho, will it come? Rho goes, only cos phi ex remains. Then here again rho goes, sin phi ey remains. So what remains left? Since z does not depend on rho, the derivative of z with respect to rho is written as 0 times ez. In the same way, if you want to find e phi, but let's start from here first, how will e phi be? According to the formula of above, will 1 over h phi be the derivative of dr according to d phi? Yes, it will be. We said in the previous video how to keep in mind that h phi is rho. We proved how it was written in previous videos. Okay. It says take the derivative of r according to phi to me. Let's take the derivative here. While taking the derivative, we first need to find dr divided by d phi. This equals, friends, now focus on here. When we look at y, I will derive according to whom? According to phi. Let's pay attention. What is the derivative of cos phi? Is it minus sine? Yes, right. Rho will remain the same. Sin phi ex. In the same way, what is the derivative of sine phi according to phi? When we take the derivative of rho cos phi ey, that with respect to phi, it is again 0 because it is not connected to phi, just as it is at the top. Well, let's continue. Notice that we just found E rho. It's good. But did we find E phi? No. Because what it tells me here, after you take the derivative, multiply it by 1 over rho, then ultimately E phi is like this. What tells me if you multiply the derivative you took by 1 divided rho, you find E phi. Okay, then we'll each simplify by rho. Here if I multiply it by 1 over rho, here rho's will go and will not affect here because it is 0. Then to find E phi like this, can we find E phi like this? Minus sine phi ex plus cos phi ey plus 0 ez. This is also very nice. I have also found E phi. Look, if you pay attention to the relationships I have found, let's find pay now. Let's write Ez here again like this. Ez is equal to Z according to the formula here again, 1 over hz dr over dz. So who can I find here? It says to me, again, take the derivative with respect to z. Multiply by hz. I know it's because hz is length. So let's see dr divided by dz. Let's find it. What is dr over dz? I focus on r again. Here is I only third term connected to z. The others are not connected to z. So does that come? 0 times ex plus 0 times ey. What's the derivative of z? 1 times ez. Now guys, who I have right now, I have E rho, I have E phi and Ez, right? Now, if I want to convert this to a matrix system, then notice that it is all written in terms of Cartesian coordinate system elements Ex, Ey and Ez. So I can express it as follows. So I can say, for example, I'm looking here for equals of E rho, E phi, Ez. Okay. Again, I am looking for the equations in terms of whom this matrix will be filled in terms of Ex, Ey, and Ez. I already found it. See, what E rho is here? X times cos phi. How was the multiplication operation in a matrix like this? I take this line and multiply it by this line exactly as it is. I am going to write 3 elements here, first, second, third. This first element will be multiplied by this element plus this will be multiplied by this plus this times this. The result is equal to E rho. Then, who are the elements that will come here in this operation? Here I am looking at with whom Ex multiplied cos phi in the exact multiplication. Then what will be here? Cos phi. Then with whom is sine phi. Sine phi multiplied by whom? Ey in the second row. I is sine times Ey. Who will be in the third row? Must be 0. With whom must it multiply? Ez. Then what will come here? 0. In the second case, I put E phi in the same way in matrix system. Look, who is multiplying by e by x minus sin phi. Okay, good. Who is multiplying by ey cos phi, which is again 0 times ez at the end times the third terms times and third term. Afterwards, I will find who I'll find again with ex. I'm trying to find ez. The logic of this event is that ez should come exactly to z. That's 0 times ex, then it's going to be 0 here. 0 times ey, who is going to be multiplied by ez. 1. For example, how cylindrical coordinates can be obtained from Cartesian coordinates in these coordinate systems, which are given to us in famous books using this matrix system. And very easy, my friends here, those who take linear lessons now. Just take your transposition. What is the transposition? The rows being columns, so if I make rows as columns, this is done. Look, I will make the lines. I take this here, I threw them this way. So first of all, I wrote ex, ey, and ez here. I set it equals, I keep waiting here again. Who am I taking here? E rho, e phi, and ez. Look now. The only thing you will do is to make rows columns. Who is my first row here? All I will do is make this row column. Look, I am doing it. I normally line cos phi, sin phi, sin phi was 0. I'm making these columns as they are. I made a column as you can see, cos phi, sin phi 0. I'm making the second row the second column. My second row begins with whom? Minus sin phi. The row continues with what? Cos phi. But what is it now in the column at it ends with a 0? It is no longer in the row, but in the column. It will be the column as in the following row. Now the element of the new column 0 is the second element of the row. Now the second element of the column and 1 is already last element of the column. It is written like this. Before knowing this inference, we memorize it as follows. We would say that the sign of the sign change, yes, right, but the important thing here is to know that this logic and it comes from transpose. For example, if there is a matrix A and the result of all is A, then this is the transposition of A. So this was the relation between cylindrical coordinates and Cartesian coordinates. Now, let's do the same thing with the cylindrical coordinates. Now, what was our formula? It is always good to repeat it, friends. Some of our friends may say that we have learned it immediately and we do not need to repeat it. While some friends may be thinking about it, what was the formula? It was good. If we write again, we continue. We say it is useful to remember. Okay, guys. Now, let's say I need ER from the global staff at first. What is my formula? 1 over HR times the derivative of R over there with respect to R. Now, I know that H rho is 1 here already. It will be enough to take the direct derivative. Now let's do it like this. Let's write R. What was R in cylindrical coordinates? As spherical coordinates. Let's first remember that rho cos phi ex. Of course, let's write a cylindrical here first. Let's go through there we will have progressed by understanding the logic. Rho sine phi EY plus ZEZ. Now, of course, let's write this right here, this cylindrical coordinates. If you want to start here, since it will be a little long, now I'm writing the one for the spherical. Let's write the R for the spherical. Now, if you remember, I gave you that rho is R sine theta. So, where I see rho, I write R sine theta cos phi EX R sine theta cos phi EX plus R sine theta sine phi EY, and there we set what that is R cos theta EZ. Now friends, I need to reach my ER. It says to me for ER, directly do dr over R. Well, I'm doing it too. I took derivative according to R, sine theta cos phi EX plus, look, if you are paying attention, the only place I go to by here is to know this formula, but I don't know the matrix by here, but the last thing we have to do is just do the operation. You are already aware of this. There is nothing I have memorized here. This is a very good example in terms of settling the logic. If I take derivatives back to R, who remains here, sine theta sine phi EY, and here I write the derivative of R as cos theta EZ. I write like this. Okay, nice. I found the ER. Now, for whom I have to do the same operation. Let's try to find E theta. What does my formula say to me in E theta? Write H theta. We know what that H theta is, R. Okay. Then is that I need to find 1 over dr d theta. Okay, we have to find it. First, let me find the multiply by a divisor at last. Then first take derivative according to theta. If we take a derivative with respect to theta, is this handful? R cos theta cos phi EX plus R cos theta sine phi EY, and here minus R sine theta EZ, because cos theta is here. We wrote like that because of the cos theta is here. Well, what does it say here? If I multiply 1 over R here, I will create E theta. So now this equals not equality because I did not divide it by R here. Then this equality is achieved after dividing. I threw them away. This equality has now been achieved. Finally, who shall we find? Let's find E phi. Let's find the last direction vector of the global coordinate system, spherical coordinate system. Here, he wants to us find 1 over h phi dr divided by d phi. Let's find it. Okay. We know that h phi was rho. I repeat, it is h phi is rho. But since it has nothing to do with rho here, I write it with r sine theta, which is equal to rho, right? Which is its expression with the rest of the elements. This time, and then what it's tell me, I drive dr according to phi. This time, because I'm on this phi, now he says to me again, take the derivative according to phi. That r always focus on this r. Take the derivative of this r according to phi to me. Finally, divide all sides by r sine theta. Okay, before I take derivative according to phi, look, there is a cos phi here. Since it is cos related to phi, I have to take as minus. The derivative of sine, cosine with respect to phi is minus sine. Here r sine theta minus sine phi ex. In the same way, this time there is sine phi, then its derivative is co phi, so here will remain plus r sine theta cos phi ey, and since there is nothing according to phi here, it means phi according to our derivative is 0. Now that I understand that, what I have right now, as you can see, there are ER in terms of EX, EY, EZ. They all depend on EX, EY, EZ. Very nice. So let me form what I just created. What we said, ER, E theta, E phi equal to what? In terms of Cartesian coordinates. What are we going to do now? As I will write a little more, I made the gap a little more in this matrix compared to previous matrix, as it seems. Who will be multiplied again? It's going to be multiplied by EY, EX, and EZ. Okay, fine. Again, in exact products, ER is equal to ER sine theta cos phi is multiplied by EX. So I wrote the sine theta cos phi, which will be multiplied by this EX. E is sin theta, sin phi to be multiplied by y, cos theta to be multiplied by EZ. Then I come to E theta. We look at who multiplies by whom. Here r's were simplified, then cos theta, cos phi multiplied by EX. So I wrote cos phi with cos theta here. Then cos theta is multiplied by sine phi EY. Then this will come here. We are looking at the multiplication by EZ. You know the third elements. I wrote here minus sine E theta. Finally, there was E phi left. There was a place in E phi where we had to correct. What I am doing to correct this inequality here, I had to simplify with r sine theta. R sine theta erase I. R sine theta I erase everywhere I see. Okay. Then here r sine theta is what is left, minus sine phi. Look, we can notice that mistakes we made because we did not memorize. This is one of the best benefits of not doing it by rote. Here, let's start again. Minus sine phi here plus cos phi left, with whom it is multiplied by cos phi EY. So in the same way that in the second row here is 0. If you have a spherical coordinate system equality or a cylindrical coordinate system equality, you can use the matrix system using this way. Okay. Well, if the opposite happens of this, so I have something in terms of spherical coordinates. How do I convert? How do I convert it to Cartesian coordinates? Again, the same logic as before. Let's call it b times b this times. This b then becomes the transposition of this b. So this time over here, Ex, Ey, Ez. I open here again, then Er, E theta, if I came here, as we said, we get transpose. As we said, rows will be columns in transpose. I will make the column here as it is. So sine theta cos phi, sine theta sine phi. Look, I'm writing this line right now. I wrote this first. I fill in the first column. The second element of the first column, I wrote this. The third element, I write this, cos theta. Then I will make the column again as in the second row. Cos theta, cos phi, cos theta, cos phi, minus sine theta. Finally, I make my last row in the last column. The last row starts with minus sine phi, continues with cos phi, and ends with 0. Guys, if you have something in terms of spherical coordinates and you want to pass it to Cartesian coordinates, you can do it using the transpose method. Okay, transposition method. Well, I have a spherical in my hand, but this time I want to switch from a spherical to a cylinder. That is what I have just given. Here is the previous method. You first pass to Cartesian and then from the Cartesian to the cylinder. So you can make this transition in two ways, friends. Okay? So, if you have anything in terms of spherical coordinates, first you find to write there instead of Ex, you write it instead of Ex. This time you will find you wrote in this way. This time, guys. So, you can reach like that. You just know these two, okay? So once we know these two subtractions, we can turn them all together, okay? Guys, when we create this, you already create the other one, okay? Thank you for listening. Hope to see you in the next video.